Once again, this is the Apache Pinot real-time analytics workshop. Just to give me an idea where we are on understanding what's Apache Pinot, what's the real-time analytics. How many of you heard about Apache Pinot before? Okay, a few people. 1, 2, makes 2 of us. It's good. Anyone using technologies that's similar to Apache Pinot? Maybe ClickHouse, maybe Druid, maybe Snowflake, maybe... Okay, so it looks like people just want to spend a good time here, so they may not introduced to the topic, which is okay. That's my favorite crowd. As I mentioned in the very beginning, it is a hands-on. It can be hands-on. I will be doing some hands-on keyboard stuff, but this is the quick start that we're going to be using. Relatively simple example, and you will understand why I said relatively, because we're going to be talking about quite complex distributed system, but I want to show this from perspective of users and talk a little bit about architecture of the system. My name is Viktor Gamov. I work as a head of developer advocacy at a company called StarTree. At the StarTree, we do contribute a lot to Apache Pinot and the open source project that surround Apache Pinot, called Site, which is SQL engine that we use, some other components, maybe Kafka a little bit on some other technologies. And my responsibility is to talk developers, explain developers the ideas behind Apache Pinot. Apache Pinot it's a OLAP database, quite modern and quite fast, and you will understand why if you stick around till the end. So this is why I mentioned that this is a relatively simple example, because I tend to build highly scalable and highly available hello world applications. Sometimes, most of the times, they will be slightly over-engineered, but the goal to show you that what is possible, but not what the system will be doing out of the box. So that's why to point some of the things, it needs to be exaggerated on purpose. So before we start, I just want to put us in a position where you understand where we're standing with this real-time analytics things. What's the breakdown? Like, do we have people who develop applications, people DBAs, people maintaining the infrastructure, DBAs, developers? What kind of crowd? People, talk to me. Help me to understand what's yes, infrastructure, like VMs, bare metal, Kubernetes, this kind of stuff. Yeah. So even lower level.
No, like platform stuff, Kubernetes, all this stuff.
Nice. Okay, cool. Anyone else? Any people who take in data, somehow touching data, maybe doing something with data to, maybe building reports for your boss? Say it again? I'm not sure I understand. Custo? What is that?
Azure Log Analytics.
Okay, interesting. I need to check that, because the first time I've been hearing this one. Gotta check afterwards. So, in this particular set of slides, I will put the landscape of the technology. So, on the x-axis, we have internal and versus external. Let me see if my thingy works. Thingy is not doing anything. Anyway, so the internal on the, I'm showing this with right hand, external, and batch in the real time. So usually, if we're talking about stuff like reporting, any type of things that, imagine someone who has a corner office in the morning, they need to have 20 pages report to analyze what happened for the last week in the company business, so they make important decisions. So this is type of reporting I'm talking about, kind of stuff that you're running maybe once a day based on the data that came yesterday. So in this case, it's the batching system, so data will wait until data fully arrived, and after that we'll run this report. We want to build some sort of dashboard that is internal, meaning that we're not exposing this to our customers. It's not core business for us. We're not selling this data. We're not showing this data to anyone else except the people who are responsible for running this business. Now, when we start going into real time, we're usually talking about things around observability and monitoring, collecting metrics from the system, and running some sort of reports. Also dashboards. Like I've seen companies like to put some sort of like a dashboard when you come into lobby of the company and you see how all the things are going on there, usually how the systems are running, if there's outages, what's the load overage. So this is more kind of like internal analytics, but also with real-time aspect. You don't want to make a decision about the system health based on the data that came 3 days ago, because the information about the systems needs to be real time. You need to know this when the things are happening. Now, with real time and external, we're going to be talking about user-facing analytics, and I'll show you kind of like few examples how the businesses use real-time analytics, where the part of this user-facing analytic is something that their customers would be interested into. And it can be still batch and external. You prepare a report and ship this as PDF. So it's still batch. It's still not real time, but there's some money exchange involved. So the people would be interested to get some sort of reports. You have a data, you generate reports, you ship it this outside. In terms of software landscape, where we're standing with all these tools, again, when I said legacy, I don't mean any disrespect. There's some tools that people tend to use for data warehousing. There's Netezza of the world. There's some Teradata's of the world and stuff like that. People tend to use Hadoop for running this kind of batch and internal analytical workloads. Snowflake is the big player here. Trino, Presto, technologies that allows to do some sort of federated queries on top of this data. Because they provide multiple connectors to different systems and allow to do SQL queries to this data. Now, Datadog is primarily main player across the real-time analytical workloads for your internal consumption. You can build something on top of things like Grafana. Prometheus is also quite popular stack if you try to host something yourself. Now, with external batch analytics, same players there. There would be some additional layer of caching. You can put this somewhere as like file results, if it's like PDF something, or you can store this in some database that would be used as the source to deliver this to the application. Now, with the real-time analytics, the people start building analytical applications and expose this as user-faced features with the systems that were designed for this type of purposes. And there would be a few characteristics they're going to share in a few seconds that will distinguish the world of real-time analytics for the rest of the world. ClickHouse is quite popular. The RockStats is a SaaS-based solution that allows people to do the stuff with their real-time analytics, and Apache Pinot that I will be talking today about. So we have an interruption from our sponsor. I'm just kidding. So next month in May, we're going to host the Real-Time Analytics Summit in San Jose, California. I will be holding a full-day training for whatever, Apache Kafka, Pinot, Apache Flink, all things of data, all things building, streaming, data pipelines. If you're interested in this type of jazz, and if you know someone who would be interested, take the picture. I was able to get the 35% off discount code only today, you know how it goes. Anyway, let's continue. So now, when you understand where we're standing in terms of the rest of the tools, who use this? And one of the examples that is basically used to describe how the Pinot was created was a LinkedIn, because it was created in LinkedIn by LinkedIn engineers to solve a very LinkedIn problem, specifically about the numbers of this very LinkedIn problem. So total number of users who will be using these features would be hundreds of million people. So you see the scale, the vast scale of the users who will be using the feature. Queries per second, would be hundred thousands of queries per second, so the system needs to be able to hold those type of number of requests. And SLA, in terms of how fast this request needs to be returned to the front end that will be displaying this, is a millisecond, hundreds of milliseconds, give or take, like 99 percentile. Majority of the queries should return less than 100 milliseconds. And data freshness, like when this data arrived and how fast we can query this is important because the data freshness in a second. What I like about this particular use case is like, this is where the company that already had all this data. So LinkedIn, every time you go in LinkedIn, like first of all, how many of you use LinkedIn? How many of you use LinkedIn today? All right, so the interesting thing about this type of use case, and it's somehow related, is that if I would ask you the same questions 5 years ago, you're probably saying, yeah, I mean, I'll check my LinkedIn maybe once a month or something like that, or update my resume. Now, we check this today because every time you do anything on the LinkedIn, you're clicking around, you're posting, you're liking and stuff like that, it generates an event that goes into this big system called Apache Kafka. Also was designed and developed in LinkedIn and open sourced. And yeah, I wrote the book about Apache Kafka, so Google me. So this system is designed to be capture all the events that happen in this big social network called LinkedIn. Now they have this data. They have a stream of events happen. Someone updated their profile. Someone updated news. Someone said that they changed the job. And also, they know anytime anyone will click on your profile. Now, you also want to know this information. Why? I'll give you an example. A friend of mine, he actually shared with me this example because I was like, whatever. And he was like, no, this is very important because if I go to interview to some company, and after that, if I will go to this dashboard immediately, and if I see someone from that company already look at me and maybe they're already on step above of my interviewer, I would say that I have a pretty good chances to go to the next stage of this interview. Plus, it's also a good thing to check because, you know, if some like CEO or some like VP of something, of engineering, of AI, checking out your profile, I feel like, oh yeah, probably I know a few things about this and people checking my profile. So anyway, so this is very analytical task because it has different dimensions and many data points. Dimensions like who from the company checked my profile? From what company? When? It was like last week, this week, 5 minutes ago. So there will be multiple dimensions for this query. And that's typical how things happen in the big world. They start using technology that was not intended to be used. They start to tackle this task to display this information because apparently people like to check who checked their profiles. It becomes a very cool feature that increase engagement of LinkedIn significantly. So they start using the tools that were available for them that time. They start using Elasticsearch to build this type of database. But Elasticsearch is a great search database, not the analytical database. So over time, they got the idea how to engineer this, and they built Apache Pinot for solving this type of task. So, and now this is how it looks like. You can go and see who viewed your profile, when, how many clicks, how many times. You can see different who else viewed your profile. They can do all sorts of interesting things. Over the time, they find out, okay, so this is pretty cool technology. Can we build some other features on top of this technology? So they come up with this idea. Okay, so we have this information when everyone is posting about. How about we build very user-specific dashboard? So dashboard for this gentleman would be different from my dashboard because we were following different people, and we want to have this also in real time because, you know, it's becoming good professional network. So you can someone posted, you can say congratulate, it's thumbs up, and stuff like that. So it turns out this is also a very good analytical task because I try to kind of simplify this query, but essentially how you would build newsfeed based on the information that you already have. So essentially from we're getting data from this click stream of events that happen there, and we're getting what kind of items we want to have, like when they happened, and how we're going to feed them in our news feed. So action, item, position over time. So, and based on this information, front end can build very nice LinkedIn feed. Again, very high concurrency query, very low latency, and the data freshness in the second, also another component. Another big player and a big contributor to Apache Pinot, it's an organization called Uber. And this is an interesting thing because Uber kind of like it has two types of users. One is, you and me. Like I travel to this conference to stay in a hotel. I travel from Jersey. So like if I want to eat something, I just like order something to my hotel because I was, working on this presentation in the last minute because there's some fine fixes and stuff like that. This is how we do. But also, Uber Eats provides another type of customers. They work with the restaurants. And restaurants who are responsible for delivering food, they're in the business of like making food and sell this food. So they also want to see information, how good are they doing. So that's why Uber Eats built this application called a Restaurant Manager that everyone who is owning a restaurant and they sign up for this Uber Eats system in their restaurant, in their establishment, they now can see how the data that is flowing through the users, from the Uber, from the drivers, how this would be shown on this UI. And again, this is something that it's exposed to user. This dashboard, it's a real-time dashboard because you don't want to see the data about your restaurant when the surge is happening and you're running out of, I don't know, like burgers or stuff like that. This information allows for both parties who manage the restaurant to like manage inventory, see how many missed orders, inaccurate orders, downtime, so they can have this information not today, not tomorrow, not next week, but immediately today. High concurrency, a very low query per second latency, and freshness changes from seconds to minutes. So this is where I'm talking about, when I say real time, I mean real time in the perception of the human brain. So seconds, milliseconds, this is something that the human brain can perceive. This is where the data that we can display, it would be important. So, and all this possible with Apache Pinot. So what is Apache Pinot itself? So I spent already 15 minutes explaining the use case. I hope you understood the use case. So Apache Pinot, it's a real-time distributed OLAP database designed to serve data with low latency and high concurrency. Use cases that I showed, they examples of this type of workloads that or like data loads that Pinot will be able to solve. So latency, it's amount of time it takes us to execute particular query. Concurrency is ability to system to serve and handle many multiple queries simultaneously, and freshness, nature of the system. You've already seen some of those characteristics that I brought up from the example. Latencies, tens of milliseconds, 100 milliseconds. Concurrency, you expose this information in the form of, it can be dashboard, it can be API call, whatever. So it tend to be executed and invoked multiple times. And data needs to be available as soon as it arrives to the system. In the past, one of the kind of like not a showstopper, but at least the thing that slows things down with the analytics is that how fast your ETL can process this data, load to your analytical storage, and you will be able to execute those queries, and how fast this is going to happen. With Pinot, this freshness problem was one of the things that they were trying to solve by design. So there's multiple ways how you can ingest data from the batch sources, like files, from file system, from the blob storages, or data that comes from the event stream, like Kafka, Kinesis, Pulsar, stuff like that. So why distributed? Why so difficult? Why it requires like multiple things? I did even show you, what distributed means. But traditional databases, and when I say traditional databases, I mean in this case more OLTP databases where you care about the rate how data will be written in the system. And in order to perform this kind of like a atomic, consistent, isolated, and durable transactions, so ACID, they need to perform, the design decisions need to be made in order to collocate storage and compute, especially for running like transaction stuff. So the Pinot it actually segregates storage and compute, and that's why we have distributed cluster. Second thing is about everybody doing distributed databases these days because this is the nature of the world. And I don't know if you've seen the previous presentation that Dennis did about the distributed Postgres that was not there like 5-6 years ago. People were building some sort of kind of the master-slave architectures where you kind of like serving your reads from your replicas, and your queries might go like for master, but at some point you need to scale master. They need to build master-master type of architectures. So things will be complicated, and by the end of the day, what people start doing, they start separating the storage and compute, because your query engine would be separated from where your data will be actually stored, because you might store this distributedly. So Pinot put this stuff by design. There will be different nodes of the Pinot cluster that would be responsible for running queries and storing the data. So in this case, you can pre-allocate some sort of like resources for your computation, where your queries can be your computation and your queries can be scaled independently, because different nodes will have a different responsibilities and can have different number of those nodes. So this is true for now, because by default Apache Pinot doesn't have any concept of like tier storage, meaning that there will be some hot data available for query and some like data that will be potentially available, but we cannot or we don't need to have this data today. So Pinot does this slightly differently, but what we're doing internally at Startree, we're actually building this capability for tiered storage, because there is only a certain amount of data that will require kind of real-time access. If you need to access to some of the old data will be retrieved on demand. Comparison to when I say traditional SQL-based OLTP database, it is transaction-focused, write-heavy workloads, and they care about the isolation of particular row. When we do insert, we care that this would be atomic transaction and there would be nothing to interfere. So in order to perform analytical queries on top of the OLTP database, you will experience some sort of, what word I'm looking for? It's possible, but it's not very practical. The data is represented. You can speed up things through introducing different type of indexes. You even can pre-aggregate some stuff, but by the end of the day, you will be using some sort of ETL process in order to transform this data to extract dimensions from the metrics, and so you will be able to build different type of cubes. With OLAP, the data is organized the way, specifically for Pinot, data is designed to be organized the way that it would be ready for query. So that's why ingestion part is separated. So the stuff you cannot do insert into Pinot. You need to run the ingestion jobs either from databases, from file systems, or from Kafka. So data model, it is tables. It's an easy structure to understand. Many people already familiar with the SQL. So tabular structure, SQL for getting access to the things. Schema is defined in a special JSON that will be submitted to API to define the structure of this data. And we use SQL to express all the queries that we need to perform. again, this is the ready-to-use demo. Hopefully, I will walk you through this demo and give you an idea about what is going on here. And after that, I will continue to go deeper into architecture of the Pinot and how it works. Hopefully, it's visible somehow. Let me see if I can do this bigger. How are we looking? Okay? All right. So, if you, for some reason, will lose track of my thoughts that I will be doing right now, which is sometimes, it's very easy to do because I'm very absent-minded. But to the point is, everything that I will be telling you will be able to go back home and do this at home because everything is documented here, and you should be able to run everything without me. And there's even a quick shortcut. Like if you want to run everything, just run, where is it? One command, make, and it will make it happen. So I already have this running. So there's multiple things going on here. A few containers. We're going to talk about architecture Apache Pinot in a second. I will tell you everything what you need to know. But you see there's 3 components that we need to be using from Apache Pinot perspective. Another thing that, for example, for this particular use case, I will also use an Apache Kafka. And also, Pinot uses Apache Zookeeper to store some additional metadata. Viktor, is it possible to run Pinot? It's just like one simple command. Yes, it is possible, but it is beyond the point of this presentation. However, if you run something like this, you will be able to run the Pinot in a Docker with the quick start, which is like a simple, like all-in-one process just to play around, which is totally fine. My particular use case will include, I think the GitHub has a nice capability that can display my diagram. Yes, it can. So, this use case will involve multiple components. Apache Pinot supports batch ingestion and streaming ingestion. So that's why we'll take the file from file system and upload to Apache Pinot. I'll show you how this table would look like, what kind of queries we can execute. And I'll show you how we can take the stream of events that push them into Apache Kafka, push them in Apache Pinot, and I will be able to perform joins between data that came from the batch and data that arrives through the stream. And that's kind of like the essence that will give you understanding what is possible to do with the system, so you can dive into some of the interesting examples that we have afterwards. Apache Pinot has built in the console that allows you to perform queries. It's good enough, kind of like you will be able to run the queries, you will be able to see some results. For example, the workshop code includes use case that very near and dear to my mind. It is movie. I love movies. I love watching movies. I love learning about movies. I love understanding the business around movies, cinematography, like how the movie made and how the movie sold and all these kind of things. I love this stuff. This is kind of simple snippet into my life where the people like to know rating about movies these days. All of a sudden, everyone is critic these days. No one is watching movies anymore. Everyone is just like criticizing movies for the sake of getting like clicks or impressions or whatnot. But beyond the point, I have a collection of the movies that I stored in my file, and also I have a click stream of ratings when the people go on the website and start saying like, that was terrible. They're using different language to say this. And they put in bad ratings. Or if it's Christopher Nolan movies, people will be, yay, let's go, the best movie ever, until the next movie of Christopher Nolan will come in. So one use case, it is example of the traditional, the batch style of data. Some sort of product catalog that data is not changing often. You can load this from the system. And example of the streaming data where data is changing in the seconds. So data will arrive into the system, and we want to use this kind of like join this data and see what kind of results we can get. All right. So one of the examples, the way how it looks like, so movie ratings table. If I run this, The query took me time used at 3 milliseconds. And if I will just do count, probably would be even faster. But I will give you an idea how many movie ratings table I have. So it is something around a lot. I don't know, what kind of number is this? 1, 2, 3, 3 million. 3 million records of the movie ratings. And this number is actually changing constantly. Supposed to. Not supposed to, because I have application that runs this, and after that stops up at some point. Let's see. Yeah, my producers died. Let me restart the producer. And this number should start changing. Yeah. So now this number changing, data flowing, and the movie ratings are generated. If I run this, or I can run stuff like data is already loaded in the Pinot, so I can do where title, like, let's do this. It's the best Christmas movie ever. Yeah, I do have a few movies that have a title, Lethal Weapon. Who disagrees that is the greatest Christmas movie? It's a great Christmas movie. It's fantastic. It starts literally with Jingle Bell Rock, right? Some of you maybe don't remember. I highly recommend rewatch this. It's a great movie. And the Riggs does arresting the drug dealers. Where? In a Christmas tree market. Christmas tree market. Some people can argue that Die Hard is the best the Christmas movie. It's a tie. For me, it's a tie, but I am a huge fan of the Mel Gibson's work in this particular movie, so I love it. Yeah, so what I was talking about the movies. So you can run multiple different type of queries here. But where's my query? So if I want to do, say, so what this query will do, it will join two tables. Let me quickly show you, you will be able to see it. Join two tables. One is the movie information. I join this with the ratings information, where movie IDs for the movie and movie ID for the rating also equal. I want to see ratings is that more than 0.9. And I want to get some information about the this movie. So when I will execute this, I should be able to get the error, and I get the error. The reason for that, because the join was introduced as a kind of like a multi-stage query that allows us to, and it will require this check mark to be executed. So when I run this query now, right? Let's see what this says. Cannot build memory hash table because, so looks like it was not that scalable after all, right? But again, it runs with the small, what word I'm looking for? On teeny tiny laptop. Let me start over because it looks like I run out of the allocated space. While it will be restarting, I will continue talking a little bit about architecture. So inside the table, so we do have this table concept, like a traditional database concept, but it's just a metaphor, it's just a concept. So it's a unit of data storage. Your data stored in table, that's what I say. Like if you want to go to query this, you say, hey, I want to go and query this table. Tables are composed with columns and rows. It's nothing special. But the tables need to be kind of like infinite. Schema defined in a table configuration file and can be offline in real time. So it's kind of funny. You can have offline tables that technically not offline because you will be able to query those. But it's just a name for the tables where you load data from your file or for your database, from whatever. But there's no online table. There's a real-time table, which is a real-time table that supports, like absorbs when we streaming data from a streaming source. And the reason for that they have like a different concepts, the way how the data will arrive. So for example, for offline tables, the batch job that will be loading data from files into Pinot will load data first into things called segments. We're going to talk about segments in a second. And after that, the segments will make kind of like attached to the table. So that's why when I said that the computation in the query engine, they disconnected. Even ingestion data is disconnected from this cycle. Now, for the real-time tables, it's a different approach where the segments will be created in memory, and after that, over the time, they will be dumped into the file segments. Yeah, so the columns, metric or dimension or date time. So segments. Segments, it's the unit of storage. It's actual files where this data is stored. If you run any type of distributed system, you probably heard words partitions, shards, segments, pretty much conceptually the same thing. But you are, as a user, you're not operating with those segments. You talking to tables. You're writing queries, you're getting results, result set from queries, shards, or like the segments is something that your operation people will be talking more if they need to do kind of like a backup restore. As I mentioned, the flight table segments created outside of Pinot and pushed the kind of like to the cluster and make them available for queries through the calling of the REST API. Real-time tables created automatically from events. We have different utilities that support loading existing files. It's CC file, JSON file, Avro, Parquet, all sorts of data formats supported. I want to show you, let me run this one more time while I will be showing you configuration. So, two tables I mentioned. One is movies, and this is the schema that I use for these movies. Say it has movie ID, it has name and time. I'm specifying, and it might include a list of values. So for example, if I look into, hopefully it will restore my, okay, but tables is not there yet, so I'll just do it starting up. If I can make tables, can I do tables? Invalid, okay. Probably because the server is starting up. Yeah, so we'll wait for a few more seconds to load. For the schema is simple, name, its type. If you ever touched things like Avro or Protobuf, so it's some sort of like a external, the language that describes the structure of your data. So there's no create table type of queries. You use the JSON schemas to create those files. And now we need to kind of create the actual table. This is the part of the job spec, so-called job spec, for loading the segments from whatever they were. Like, for example, in files. In this particular case, it will go and read the data from folders, and the JSON would be the mask of the files, what we want to load. I want to specify that every line of this file was going to be JSON record, so it's not like one giant JSON, it's just JSON objects per line, so technically it's not JSON, it's more like JSON lines or whatnot. And this is where this thing would be available inside the Pinot, like it will be stored inside the schema, and data will land into this controller, will be responsible for creating the tables, creating the segments for those tables, and so far and so on. Oops. Now, let's see if we're live. Yes, we're live. Let's see one more time. Inside this console, I also will be able to see all those things that happens here in this particular case. Where's my table? I will be able to show you query console, tables. schema will be retrieved from this, from the query console. We'll be able to see the schema. And when I run this query, let me see if my select will be working, so we can continue. Yeah, boy. Okay. Nothing found. Why is that? Make ingest import. Import. If data is not floating, meaning data from Kafka is not there yet. Here we go. So this is like a join that provides the rating for the movie, and we will be able to see like the highest rated movies, how the rating went from 6.5 to 10. The way how it worked in this particular use case, the rating generator is super dumb. It just uses whatever random function is available. But probably I can make it something more interesting if I would use some sort of like the mathematically correct with normal distribution type of like a random generator. But hey, it's just good enough for the demo. Yeah, so this is, in this case, it runs a join query. Data from the ratings that will arrive, this data already available. So if I will rerun this query, say, for example, I refresh my dashboard and I want to see that new top ratings. So in this case, I'll run it one more time. Number of documents scanned, meaning that this is amount of records that we collected for this particular use case. So it is pretty fun. Now for streaming data, so rating schema, exactly the same. What you expect, the schema name. There's a definition for different fields. And again, when we go into these movie ratings, the schema showed in this side of screen. So you can see here, you can play around with this and see what you have there. But the configuration is different. So the offline table requires the job spec to push this data into Pinot, where with the ratings table, when we're creating configuration for this table, we're specifying this so-called streams config. For the stream config, we're showing that, hey, there's a Apache Kafka running here on this particular port, and the records, that every record that happens in Kafka will be JSON records, so push this JSON record inside the Pinot. And if I run this something like Kafka console consumer, so this is like command line tool that allows me to query, not a query, but get all the data from Kafka topic and see like if the data is still generated. 3, 2, 1, go. 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 3, 2, 1, go. Should be there. Unless I already loaded that 3 million of records. Let's see if I just do this one. Count. Run query. No, it should be outputting something. I don't remember how to do reset of set.
So did you run the first?
Yeah. Say it again?
I ran it, it's working for me. I think the first one was missing.
Created topic? Topic is already created. Yeah, I think topic is created. Because, you know, the way how I know this, the rating data is going here. So if I'll just do count. Okay, I know. So let me do this one more time. If I will just do this guy, I need to run this indefinitely. Now there's a limit says in your Docker Compose. If you go to your Docker Compose, you can find there's limit of 1 million records. So when I will run this, I need to change this to something that will work for the sake of demo. So in this case, if I run this, console consumer, I should get all these messages that go into this Kafka topic. Yeah, so all these ratings is generated again. There's some Python script generates this, so that data will be flowing. Another 1 million of records will go here. So that's the table. Let me show you how it looks. So table. Each table will include multiple different segments. Number of segments can be configured, or like there will be some defaults. And this is where the things get a little bit interesting. So the segment structure is columnar structure, meaning that it's not a record base, it's not like a row base, it's column base. And so we take the value, it's going to be our column name, and all values for this particular let me show you. So for example, I have this the data beat from clickstream, IP address, user ID, remote user. So the way how it will be stored inside the segment is like this. So we have each individual record will be split into this kind of like column name and the value. And it will be different from the way how it stores inside the OLTP database, because you will record this thing as is, and you care that this record will be recorded without corruption. So on example of IP address, like we have hundreds of these clickstream events that we collected this. Now for each IP address, we store all possible values of this IP address, something like this. So that's columnar form. Instead of storing the data in the record format, we transform it. Why? Because columnar format allows us to do multiple things. Allows us to execute queries more efficiently. And also we can do some sort of optimizations in terms of, there would be only certain, number of IP addresses to the point where they start duplicating, so we will be able to perform some sort of compression. So store instead of actual value, we can store dictionary that will be pointing to like number of IP addresses, and actual value, and we'll store this dictionary ID inside this record. So it allows us to do some sort of optimizations. Any questions about this part, about segments? When I ask this question and I hear the silence, there means two things. Everything is clear or nothing is clear. And since it's silence there, for me it's also not clear which one is which. So you tell me if it's everything is clear or nothing is clear. Nothing is clear. Fantastic. Yes, I'm doing such a great job. What exactly not clear? So do it again what? Explanation about segments? Yeah. Okay, so we have a slide for that. And this slide is like this. Where is it? Yeah, this one. So table is a metaphor, it's abstraction. It doesn't exist. It's a fairy dust. Which movie?
I think it's Wall Street.
My man knows my movies, yes. So it's a concept because we need to communicate on some sort of abstraction. So table is something that exposed to application developers. You query a table. As operations person, when you run this cluster, you scale those things, you care about how data will be actually physically stored because you need to pick up the storage that you will be using. It's going to be file system, network attached drives. It's going to be, I don't know, the stuff with the Minio and all sorts of blob storage and all these kind of things. So those segments, you're not touching as a developer because the server, it's one of the components that I will be talking in a second. Server will be responsible for handling and serving those segments. There's another component that will be responsible to getting queries and send the workloads, and I will have a slide in a few seconds. So those segments have structure as a columnar. We're not storing individual record. We store the value of this record based on, we're expecting this data will come in tabular format. So that's why you're defining the schema. And that's why we're storing, instead of like one record, it's highly, what's called, like denormalized form. Like in the computer science schools, they will teach us about third normal form, where in our SQL database, we're not storing duplicates. We throw away this theory multiple times per last 10 years with introduction on NoSQL databases and all these kind of things, because it's okay if you have a duplicate. Same thing with here. Like we're dumping here everything, and there would be some duplicates here with IP addresses. We can optimize it. It's our responsibility. It's not something that we impose to our users. Let me finish quickly about servers and brokers, and we can talk about certain things afterwards. So there's 3 components that is available in terms of like type of instances that are running inside Pinot. We do have a servers. This is where those components will be responsible for managing a segment. So servers, they serve segments. Super clever name, I think. So every server will have these multiple segments. They will be stored on one server. Multiple servers available in clusters, multiple segments distributed across multiple servers, and more importantly, they also can be replicas of those segments across the servers in order to perform, if something will go down, so the replicas will be available to serve data. Brokers, it's a different type of, so that's why in my demo I have one server, one broker, one controller. Broker is responsible for receiving requests. So think about something that this is going to be, the servers will be responsible for storage, brokers will be responsible for compute, because they will perform this scatter and gather type of pattern. When we send the query, broker will send the query to all the servers, collect the data, and represent this data for us. Brokers, if we do select, goes to select. In only 2 segments will be required. Broker knows the mapping about the segments. And it will go only to the servers that host those segments. And the server will collect the local data and ship this data back to broker. There's also a concept of deep store where the segments can be sent somewhere where the cluster can be rehydrated after restart. So it's not something that, it's not a tier storage, it's something that you can use potentially for disaster recovery. You can offload this to S3 and the cluster will then go down. You restart this, you have reload data from deep store, so you don't need to do ingestion jobs one more time. HDFS and S3 is supported as a deep store. There's another component that's called a controller that will be responsible for management the consensus between the nodes and responsible for switching to detecting node failures, segment assignments, replication management, etc. Stores all the global metadata, so that's why the broker knows which server holds particular segments, and it maintains information about how the segments mapped between the servers. So let's have this picture one more time. We use also Apache Zookeeper to store some of the metadata there. And segments, clients talk to brokers. Brokers will be responsible for your queries again. Controller know and tell the broker where the metadata is stored. So last but not least, we do have the multi-tenancy concept built in. So if you try to build something that will, where you can segregate different type of tables between different use cases, so different departments can run on top of one, same cluster, but you want them not to see queries or tables of each other. So you will be able to segregate this with concept of tags. We can manage the specify tenant tag for a particular broker and segregate different queries. So in this particular case, broker, tenant A, and the brokers and servers belong to tenant B. So that allows you to build some sort of like internal multi-tenant infrastructure. Now, this, one more time, this is where this workshop code is hosted. Very simple architecture. Play around, let me know, because we do have a Slack community for Apache Pinot for all sorts of questions with regards to architecture, troubleshooting, what kind of questions you have, maybe like you stuck with somewhere, you can ask the expert on the community. And also we have a Slack for Startree, if you using any stuff from for Startree Cloud, Third Eye, Data Manager, we also have a Slack there. With this, I guess I'm running out of time. My name is Viktor Gamov, and as always, have a wonderful day. And if you have any questions, I'm still available for some enhanced interrogation if you have any questions about this. But I really, really, really want you to look at this one and let me know either in Slack or GitHub issues how it go or what kind of like use case you might see here. All right? Class dismissed. Thank you.